So I forgot one thing. I don't know how I forgot it. I was looking right at it. We need to do problem 4 on 12.2, which is the opposite. We're going to be given numbers in scientific notation, and we're going to convert them into standard form. So let's look at the first one. Again, it's not difficult, and just thinking about things right at the very beginning will help you not make mistakes. So we're given 1.03 times 10 to the 6th. So 10 to the 6 is a big number. 10 to the 6 is equal to 1 with 6 zeros. So that's a really big number. So I'm going to be multiplying a really big number, 10 to the 6 times 1.03. And since D, this is my D value here, this is D times 10 to the n. And I already know, since I've been given a number in scientific notation, that D is always going to be greater than or equal to 1 but less than 10. So that means that whatever this number is here, it's going to be larger. The end result of multiplying something greater than 1 times something really, really large is going to be a really, really large number, something actually greater than 10.6. So the only reason I'm saying that is it tells you which direction to move the decimal. So if you want, in preparation, you can add 6 decimals. Now we're not going to use, 6 zeros. We're not going to end up using all of them. It's just mindless. 1, 2, 3, 4, 5, 6. So I'm just literally looking at that, but I'm not going to use them all. I'm going to take my original decimal and I'm going to move it. I've got to make 1.03 to be a larger number. So I'm going to move it 1 place, 2 places, 3 places, 4 places, 5 places, 6 places. So I don't need these zeros. I overdid it by 2. And some of you can already see exactly how many places you need to, but you don't have to worry about that. You just need to add some zero space. It's kind of like white space to work with. I call it zero space. So the end result is 1, 0, 3, 1, 2, 3, 4, with 1, 2, 3, 4 zeros. And we see our resulting number is 1,030,000, which is greater than 1 million. So that's how I converted 1.03 times 10 to the 6th. Let's do it with question B. Now in this case we have 8.7 times 10 to the minus 3. No, sorry, 10 to the minus 5. Now 10 to the minus 5 is equal to 1 over 10 to the 5th. Just move the exponents there, right? Using what we just learned. So that's a really small number. So again, write your 8.7 here, and you're going to make this into a smaller number. So if you want, you can just mindlessly write 5 zeros on this side. Now you won't need all of them, but you certainly have plenty of zero space there, and you're going to move your decimal to the left 5 places. So there I'm moving it 1 place, 2 places, 3 places, 4 places, 5 places. So the end result, including my leading zero, is 0.0000087. So these two are the same. So 6.003 times 10 to the 10th. Since that's a positive exponent, I'm going to be moving decimal places to the right. And I want to add some zero space. So I added 10 zeros. That's going to be more than enough. But it doesn't matter if it's more than enough. What I have over, I will just move. So I'm going to take my decimal and I'm going to move it 10 places to the right. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Put it right there. And I can erase my zero space. And when I rewrite the answer, it's going to be 6, 0, 0, 3, 0, 0, 0, 0, 0, 0, 0. You don't have to put that decimal in, but you can group your zeros or your digits in groups of threes. So it's units, thousands, millions. So this is 60 billion, 30 million. So that's a huge number. That's often the case in scientific notation. It's the very reason we invented this type of notation, is to get rid of that really large zero space there. One last one. And this is 4D. So 2.02. Remember, this is our D value. It's always going to be greater than 1 but less than 10 times 10 to the minus 3. So since that's a negative, I'm going to take my original and I'm going to add my zero space on the left. 1, 2, 3. So that's going to be enough or more than enough. So I take my decimal and I move it 3 places. Not minus 3, just 3. Always just take the absolute value. But I'm moving it in the same direction that I added my zeros. So that's 1 space, 2 space, 3 spaces. So my end result, together with my leading zero, is 0.00203. Remember, this means I'm moving the decimal place, and that's the end of it. So I will either post this as a special little, its own separate video, or I'll try to attach it at the very end of the previous video.